Video, we'll be looking at mission fails that don't involve human disaster. History shows that it was in the 1960s that space exploration really started to take off. But although both NASA and the USSR enjoyed a lot of early successes, NASA suffered a hugely expensive failure in 1966, just 3 years before its famous moon landings. The first of 4 orbiting astronomical observatory satellites was launched in that year. OA-01 was loaded up with costly scientific equipment that could, among other things, detect ultraviolet, X-ray, and gamma-ray emissions. But while the launch was a success, none of those fancy instruments could ever be used because of a catastrophic power malfunction. This particular program had a follow-up failure, however, as it was the third satellite, AOA-B, that was the costliest of all, to the sum of $98.5 million, which is almost $680 million in 2021 when adjusted for inflation. It launched in 1970 with the largest space telescope ever, but due to a single bolt that failed to fire, it fell back into the atmosphere and burned up. An incredible amount of money's worth gone in a flash. We can at least be thankful that the fourth mission was much more successful, launching a UV telescope that remained operational until 1981. Otherwise, these failures might have turned us away from space telescopes for a long time. We may never have developed and launched something like the Hubble, and our view of space might never have progressed as far and as quickly as it has done. A few decades later, NASA experienced another expensive, high-profile failure. And this time, it was due to a simple error that somebody working in the agency certainly could have spotted and fixed. Launched in December 1998, the Mars Climate Orbiter journeyed for 9.5 months to the Red Planet without a hitch. All seemed to be going well. Its purpose was to study the Martian atmosphere and to relay communications for another mission, the Mars Polar Lander. However, as the Mars Climate Orbiter entered orbit around its target planet, contact was suddenly lost. After investigations, NASA realized that something rather crucial had been lost in translation between them and their contractor, Lockheed Martin. The partnered organizations had been using differing systems of measurement. This was a grave mistake where the orbiter was concerned, since when it needed to use its thrusters, it performed the calculation in pounds of force rather than newtons. Since 1 newton is 4.5 times greater than 1 pound of force, the climate orbiter approached the Martian atmosphere far, far lower than it needed to. The mission was a disaster, and to this day, it's not known whether the orbiter broke up to scatter across Martian soil or if it's still out there somewhere orbiting the Sun. Regardless, it equaled a calamitous loss of over $327 million for NASA, which took the blame for the error. What's more, to rub salt into this particular wound, the orbiter's planned partner, the Mars Polar Lander, arrived a few months later in 1999 at a cost of $165 million and also failed, crashing into the Red Planet to close an especially unsuccessful chapter in NASA history. Next, in 2011, Roscosmos, Russia's space agency, had a series of high-profile failures of their own. Most disastrously, it lost a communications satellite that had just been launched on a large Proton rocket. The Express AM-4 was placed into the wrong orbit by a faulty rocket stage and was eventually decommissioned and deorbited, splashing down into the Pacific Ocean. But ultimately and unfortunately, this was just one in a series of other rocket failures for Russia that year. It lost the Progress M12M due to malfunction, for example, just a few days before the Express AM-4 satellite. There was another in December of that year too, which mistakenly landed in Siberia very shortly after liftoff. In total, Roscosmos had 5 failed missions just in 2011, leaving Russia hundreds of millions of dollars down. More recently, in 2017, we've seen China's experimental communications satellite, Shijian-18, also fail to reach orbit, although the China National Space Agency has been tight-lipped about what went wrong here. What we do know is that it came just a few weeks after another failure, when the satellite ChinaSat-9A was stranded in a much lower than planned orbit, although this particular error was later corrected. But while NASA, Roscosmos, and the CNSA are 3 of the world's foremost space agencies, South Korea's space program is a much smaller organization, and unfortunately, it has suffered a few notorious failures as well. Its first launch vehicle, the Naro-1, failed to reach orbit during its first two flights in the summers of 2009 and 2010, respectively. It took a while for the details of the 2009 failure to be understood. Initially, it had seemed as though the mission was going as planned, but then the satellite it was carrying simply failed to send out any signals. It turned out that the malfunctioning satellite had never actually left the rocket, which had then made the rocket too heavy, causing it to crash back down to Earth with the satellite. To make matters worse, all of this happened just a week after the Naro-1 rocket's first launch attempt, which had been hurriedly canceled only a few minutes before takeoff, also at considerable cost. As for Naro-1's second failure in 2010, South Korean scientists never revealed what happened. But fortunately, the third vehicle built did have a successful launch in 2013, finally reaching low Earth orbit. In total, though, the launches cost an estimated $450 million, raising some hard questions from the public. For our penultimate failure, we're headed back to America. It's somewhat ironic for a satellite named Glory to be such an expensive disaster, but that's what happened to NASA in 2011, around the same time as those Roscosmos rockets mentioned earlier were also going wrong. Glory was a satellite designed to study the Earth's climate and provide invaluable information about global warming. It was headed to space on a Taurus XL rocket along with another satellite called KYSat-1, which was a smaller project designed so that school children could directly engage with the mission by downloading data and taking photographs of the entire planet. But none of that proved possible because it all went wrong. The fault this time lay with the rocket itself, which had a problem with its nose cone. When the nose cone was meant to detach, it didn't, meaning the rocket was too heavy, and so it plummeted down into the Pacific Ocean. Of course, in this case, we didn't only lose the eye-watering sum of $424 million that NASA had invested in the mission, but also the potential information that Glory would have sent back to Earth regarding the climate and environment, information that would surely have been useful while on the verge of a climate disaster. But finally, by far the most expensive space mission failure that didn't result in a human casualty was the Soviet Union's Salyut 2 space station failure in 1973. Salyut 1 had previously been a landmark in space exploration, becoming the first successful space station when it was put into orbit in 1971. Although its legacy is dominated by human disaster, following problems with the Soyuz 11 spacecraft, which led to the only 3 recorded deaths in outer space, also in 1971. The good news is that Salyut 2 thankfully didn't cause any further loss of life, but by purely financial measures, it was an enormous misstep. It launched in April of 1973, but was only in orbit for 2 weeks when the mission failed, before anybody could actually use it for its intended purpose. The failure was caused by Salyut 2's launch vehicle, a Proton K rocket, exploding 3 days after launch. Up until then, the mission had gone as planned, but the explosion created debris that later struck the station in such a way that it could never be used again. It's not exactly known how much money went into the development of Salyut 2, but estimates put the cost of one Salyut space station at around $500 million in the 1970s. With the rocket itself commanding a price tag of at least $60 million on top. That's about $3 billion in today's money, and a clear winner for today's video. Of course, while it's true that these examples have lost enormous sums, they've also served to teach us more about our technology and how to develop, test, and use it in the future. But regardless, those are the most expensive space mission failures.